Hey guys, in this video we're going to go over gravitational potential energy. So hopefully straight away you think, I know what gravitational potential energy is and I know which objects have gravitational potential energy. We're going to look at some exam questions as well to make sure you get all of those marks. So remember though, if you want extra revision, you can always go to my resources, that free lesson resources for you, or you can always join our live lessons. Just click the link in the description. So gravitational potential energy, hope you're thinking, of course I know what that is. That's how much energy something has because of its height above the ground, right? So let's imagine, here's my planet Earth. Hopefully we know that's the planet that we all live on. And let's imagine on planet Earth we have some worm, diagram not scale because that's a giant worm. We have some worm on the ground and we have some bird in the sky. And I asked you which one has more gravitational potential energy. Hopefully straight away you're thinking, duh, the bird has more gravitational potential energy. So I'm going to write GPE is one way you might see gravitational potential energy, or another way you might see in your exams is EP. Okay, so energy of that potential form. This is kind of the new way that we're starting to write it. This is the old way, just in case you see it in some textbooks. So gravitational potential energy, or you can write energy in that potential form. So clearly the bird has more gravitational potential energy because it is higher above the surface of the Earth. Whereas that worm is clearly on the surface of the Earth, so it's very little gravitational potential energy. Same way that if you're on the ground floor, you have very little gravitational potential energy, but maybe you're in school or maybe you're upstairs, because you're further away from the center of the Earth, you have more gravitational potential energy. So how do we calculate it? Gravitational potential energy is an equation that's on your formula sheet. Okay, but again, if you can remember it, you're more likely to get marks. So the way I learned when I was school, gravitational potential energy, we just said the more you have, the higher you are above the surface of the Earth. So I imagine that God's in heaven, so the equation then is going to be mighty God in heaven. However you remember it, it's up to you. Okay, it's irrelevant where you believe in God or not, it's supposed mighty God in heaven, right? Just help you remember it. So in your formula sheet though, it's written for you, but nice if you can remember it because it makes you faster in your exams. What it says is E stands for our energy is equal to our mass times by G. And it tells you in your formula sheet what G is, but G is your gravitational field strength. We'll come back to that in 2 seconds. Times by H, which is your height. That's your height above the ground. So your height above the ground, how high you're above the ground, is a distance, so always measured in meters. We know mass, we're in physics, and this one I'm going to put in red, if I had a red pen, because it's super important that you remember that mass in physics is measured in kilograms, right? It's measured in kilograms. Super important, because in your chemistry classes, it's measured in grams. So remember, mass in physics is measured in kilograms, because in physics, we're normally talking about these large objects. Okay, then G is that gravitational field strength. Gravitational field strength is what we use this little g for. And they'll always tell you what number to use. So I've written up here, use G is 9.8 newtons per kilogram. Okay, so that's the unit for gravitational field strength. You don't need to remember this. It will always get given to you in your exam. Again, though, it's kind of helpful to remember it. If you're doing the foundation science, they might tell you use G is 10. Okay, they're just writing it up. But most likely it'll say use G is 9.8 newtons per kilogram. What that tells you is basically how strong or how large is the planet that you're on. So this is the gravitational field strength for the Earth. So that tells me about the strength of that force pulling me down towards the center of the Earth. But if I was to go something like the moon, so we know the moon orbits the Earth. Again, diagram not to scale. But the moon, because it's much smaller, it's going to have a much smaller value for G. So G on the moon is much less. So G just tells us about like what planet we're on. So again, G for the Earth is 9.8. It'll be a different number for the moon, and it'll be a different number for like the planet Jupiter, which is really big. So again, we know that it'll always tell us which number to use. And E, like we said, is for energy, and we know energy is always measured in joules. Okay, so energy is always measured in joules. So let's have a go. So let's say we've got an orange. There's its mass and its height in a tree. Calculate its energy. So I'm thinking if something is high up in a tree, that's my buzzword, I know that it's got gravitational potential energy. So I know to look at my formula sheet and I see the equation for gravitational potential energy, or I remember about mighty God in heaven, MGH. So if I want to calculate the energy, what I need to do is use the mass. It gave me the mass in kilograms, so pretty good, 0.1, times by G. G, it told me to use 9.8, times by that height. It told me it's 20 meters up. So it's 20 meters up in a tree. And I want to calculate its gravitational potential energy. So in your calculators, what you do then is we're going to do 9.8. Remember, you always have a calculator in physics. 9.8 multiplied by 20 multiplied by 0.1 to give us a gravitational potential energy of 19.6. So 19.6, and then energy is always measured in joules. Always measured in joules. Okay. In your exam, they really like it if you lay it out like this, because remember, examiners don't have much time. They're marking so many papers, so you want to make sure it's really clear to them what your answer is. So always put your equation, put your numbers in the right place, and then your answer and the unit. Okay, just make it nicely laid out. Okay, so let's go to another example. This one says, now we've got a firework. We know the mass of the firework. It says it explodes and releases this much energy. What is its maximum height? So again, you're to see those buzzwords. We're trying to find its maximum height, and it's got to do with energy. So again, we know anything that's high above the ground has gravitational potential energy. So I write my equation that my gravitational potential energy is mighty God in heaven, mgh, and now we fill in our numbers. Energy is always the one that's measured in joules. We know that. So my energy there is going to be that number 200 equals the mass. Now, I hope you're thinking again, which is red because it's super important. They will look to see if you've noticed that unit. Remember we said mass has to be in kilograms, but here they're given to you in grams. So how I remember it is if someone was lucky enough to give me 1k of cash, give me £1,000. Someone give me 5k of cash, they give me £5,000. So we see if we want to go into K, what the math we do there is that we divide by 1,000. So what we've got is 240 grams. So I want to go into K, I want to know what that is in kilograms, I divide by 1,000. Divide by 10, divide by 100, divide by 1,000 gives me 0.24. So the mass we use down here is our 0.24, 0.24. Times by G, G again, we're using 9.8, times by the height. I hope thinking that's quite a confusing equation, right? There's a lot there to do. We can simplify it though. Some of your teachers might be like, oh, use equation triangles. That's just a cheat way to help you get marks quickly. But we want you to do A-level physics, right? We want you to be successful. And it's quite nice. You just have to practice it, but it's quite easy to rearrange equations. It just takes time and practice, okay? But we're going to practice this loads. So what I do is my 0.24 times 9.8, right? We'll make our life easy. So 0.24 times by 9.8 tells us what that number is. That number is 2.352. So what I'm going to write now is 200 is equal to, what did we just say? Well, that's why you're going to do things twice in your calculator and always write down. 0.24 times 9.8 is 2.352. 2.352 times by the height, right? So all we did was I multiplied these two numbers together because I just want to make my life easier. So I'm just going to write this here now, so we've got a bit more room. So what it says is we have 200 equals 2.352 times by the height, right? But I want to get the height by itself. So I think, how can I just get the height by itself? I want to get rid of this multiplied by 2.352. So when I get rid of that, we have to do the opposite of it. So the opposite of multiplying is divided. So what we're going to do to divide by 2.352 to get rid of it. And when we do to one side, we have to always do the other side. So this side I'm also going to divide by 2.352. So we're putting our calculator now is 200 divided by 2.352. And we're going to get an answer then of our height. My height is going to come out at 85. My calculator says 0.03, so 85.03 meters. I think 2 decimal places, so 2 numbers after the decimal place is always the best way to answer. Okay, but always double check your calculator. The amount of times people can just slip the button and hit the wrong button, all the time, even I do it. So please always double check. So again, the first thing we did was we took our 240 because it was in grams. We divide it by 1,000 in order to get into kilograms. When I put it into kilograms, I got 0.24. We said energy is mass times G times H. I simplified by doing 0.24 times 9.8, right? Because I've got 2 things multiplied here. So we multiplied them together and we got a number of 2.352 times by the height. So we just wrote this line here, so we had a bit more room. Now I want to get height by itself, so do the opposite of multiplying by 2.352. The opposite of multiplying is dividing. What we did to one side, we did to the other. So what we did was 200 divided by 2.352 to get our answer of 85.03 meters. So that's the height that my firework exploded in the sky. Remember, if you want more revision, always go to my resources to get extra help.